Hey gang, this is just a quick supplement to try and explain molar mass. I realized that y'all didn't quite get that last time in class. So, a molar mass is an umbrella term that covers a couple of other terms. It's the mass in grams of a mole of a substance. So you'll often see it written as grams per mole, okay? So, this could be a mole of atoms, such as carbon. Okay, so carbon will have a molar mass of 12.01 grams per mole. Or it could be a molar mass of a molecular substance, a covalent compound, like water, which has a molar mass of 18.02 grams per mole. Or it could be a salt, like sodium chloride, which has a molar mass of 55.89 grams per mole. So these are all molar masses, different substances, atoms or compounds of various kinds. So the way you come up with molar mass is for whatever substance, let's look at iron oxide, rust. You look at the periodic table, and you're going to need the atomic mass. So looking at iron, that's 55.85. That's iron. And oxygen is over here, and it is 15.9994. So I always round that off to 16.00 for oxygen. Now, there are two irons, so you're going to need to multiply 55.85 times 2. And there are 3 oxygens, so you're going to need to multiply that by 3. So it's going to be 111.7 for iron, plus 48.00 for oxygen. You can't read that probably. Go ahead and make those a little bit easier to read. All right, so 111.7 and 48.00. So then you go ahead and add those together. 7.951. And there's your sig figs. The molar mass of rust is 159.7 grams per mole. Okay. So that means if you have 159.7 grams of rust, you have 1 mole of rust. If you have 79.35 grams of iron, you have 1/2 mole of rust. So that is how you calculate grams per mole. You just add up the mass of every single atom, basically. Now, there are 2 directions you can go from moles. You can go to mass, and for that you'd need the molar mass. Or you can go to the number of particles, and that's where you use Avogadro's number. So let's say you have 0.375 moles of nitrogen. How many grams of nitrogen is that? Okay. Well, you're going to need the molar mass. And remember, where you're going to is what goes on top. So grams of nitrogen. All right. So the molar mass of nitrogen, well, you see the atomic mass of nitrogen is 14.01. But remember, nitrogen is one of the diatomic elements, so the molar mass of the molecule of nitrogen is 28.02 grams per mole. So then you do that math. And the answer is 10.5 grams of nitrogen. And you can go in the other direction, using Avogadro's number to find out how many particles of nitrogen that is. That's 0.375 moles of nitrogen times Avogadro's number, 6.022 times 10 to the 23rd, in this case, molecules of nitrogen per mole of nitrogen. That is 2.26 times 10 to the 23rd molecules. So, if you're going to the right, you multiply. Going to the left, you divide. For particles, let me divide by Avogadro's number. Going from moles to mass, you're going to multiply. Going from mass to moles, you're going to divide by the molar mass. Now, this is one of those things, and get it firmly in your head and practice, because while you don't use this all that often, it's very difficult to work with individual particles. We typically don't. But we do use this all the time, okay? Because moles is what we use to work with chemical reactions and so on, because it is directly related to the number of particles, and mass is what you measure in the lab. So you're going to see molar mass every day, always, for the rest of your life. I mean, at the gas station, things like that. Okay, so that hopefully will help you out a bit with doing that sort of problem. We will definitely be covering molecules and other kinds of compounds later, so don't worry too much about that right now.